morning, everyone. I would like to welcome everybody present on site at Gallos Campus Rethymno, UCRC, the University of Crete Research Center, and everybody who's present online to this hybrid hands-on workshop led by our visiting scholar, Dr. Silvia Piccini from Istituto Zampolli, Italy, who's spending a couple of weeks here working with us. So today's topic is Euclid and how to model Euclid's elements with Protege. So the floor over to Silvia.
Thanks, Maria. Thanks, everyone. Hello, everyone. Also, those are online. This 4 hours training session will be very practical. We will learn how to build an ontology by using Protege. And the topic is, as Maria said, Euclid's mathematical terminology. Before starting this very practical session, I will just briefly present, I will say just some words about Euclid's work. Okay. As you might know, sorry. Euclid's Element is one of the most influential works in the history of mathematics, and it's the main textbook used for teaching mathematics, especially geometry, from its publication until the late 19th or early 20th century. It was written by the ancient Greek mathematician Euclid, who lived in Alexandria around 3000 before Christ. Well, it's a very comprehensive compilation of all the knowledge and theories about geometry and number theories known during Euclid times. It's divided into 13 books, each covering different aspects of mathematics. Today, we will focus on the 6th book, and because Euclid in his first 6 books gave a lot of definition. He defined plane geometry, fundamental concepts, for example, related to points, lines, angles, triangles, circles, etc. He presented, specified all the properties of shapes and theorems related to congruence, similarity, and area. Today, we will work with the triangles, okay, and we will try to formally define, by using Protege, the definition Euclid gave us about triangles. So let's start building our ontology. I hope you downloaded the Protege software. Okay, everyone downloaded it. Okay, so for those online, I don't know, I can see if everything is okay, but I suppose yes. Okay. Well, a good practice before starting building an ontology is to formulate competencies questions. These are natural language interrogatives that help us to scope our ontology. These are natural language questions that we suppose our user would like to gain answers for, okay? So I tried to formulate 3 competencies questions. These 3 competencies questions that you can see on the slide are mainly focused on linguistic aspects. We are going to formalize linguistic aspects by using OntoLex-Lemon model this afternoon. For the first 2 hours, we will focus on the conceptual dimension, okay? So we will be able to answer to these questions this afternoon after all the 4 hours training session. The first one is, what are the hyponyms of the English term triangle? What are the French, Italian, and Greek translations of the term obtuse-angled triangle? And for example, what terms are used in French, English, Greek, and Italian to designate the concept of obtuse-angled triangle? This is just 3 of the many questions we can figure out, okay? So let's start. Let's start by the...
Can I ask you?
Yeah.
The hyponym?
Yeah. The definition.
Yeah.
Okay. This is a linguistic, relation, semantic relation between senses. We will see in detail this afternoon, but just to start for example, we have the term figure, okay, and this term has a sense, as a meaning. And then we have, for example, trilateral figure, okay? Figure is the hypernym of trilateral figure because its sense is figure, okay? And trilateral figure is the hyponym of figure because this senses is narrow, okay? So the broader sense is the hyponym is the narrow sense, okay? This is a relation between senses. And from a conceptual point of view, maybe these things don't overlap. We speak about ISA relation. So a triangle figure is a triangle, is a kind of triangle. But this is a conceptual relation. From a linguistic point of view, we speak about hypernym, broader meaning, and hyponym, narrower meaning, okay? No, you're welcome. Please interrupt me if you have questions. It's a pleasure. Okay, definition. I gave you the definition in ancient Greek given by Euclid. And then I also gave to you the definition, the translation of the definition in English. And we have, I underlined the concept we are dealing with today. As you can see, we have 3 different concepts: rectilinear figure, trilateral figure, and quadrilateral figure, okay? And then we have other concepts, but we will focus on those concepts later, okay? Later. We will begin with rectilinear figure, trilateral figure, and quadrilateral, okay? So let's start by opening Protégé, okay? I will start with you. We'll open, yeah. Is it fine with you, everyone? Is it okay? Okay. So here we have the tab window. Please select tabs and then activate all the tabs, okay? Because we will work with entities, with classes, with object properties. We will not see data properties, but well, maybe after in this afternoon we will be useful. Then annotation properties, just please activate all these tabs that now you can see here in the toolbar, okay? So let's start. Here you have the definition, okay? So you have to carefully read this definition and trying to figure out a hierarchy, okay? to arrange this concept in a hierarchy by identifying the most general concept, the upper classes, and then subclasses, more specific concepts, okay? So for example, which is the most general concept for you between rectilinear figure, trilateral figure, and quadrilateral figure? We will start together. I will construct the ontology together. Which is for you the most general concept, the upper class for you? Okay, so we will start by rectilinear figure, okay? That is the upper class. And then we define the subclasses of rectilinear figures that are? Okay, so let's start by arranging this entity here in the ontology. Well, we work here in this yellow box, okay? So please go on online thing, our thing. This is the first node, okay, that is given by default by Protege. So you cannot delete it in this node, okay? So by clicking here, and then we add the first subclass of our thing, that is trilateral, that is trilateral figure, yeah. No, it was rectilinear, sorry, rectilinear figure. You can enter the name. Click here. Yeah, here on add subclass, because the first class we introduce is conceived as a subclass of our thing, okay? Because this is the main node given by default by Protege. So the first class is actually a subclass, okay? The first class we are going to create. So you can enter the name and then click on OK, and we have our first class. Okay, our first concept.
No,
Yeah,
yes, exactly.
yeah, of course.
And why don't we use the figure, just the figure, as a first class?
Okay, we can.
Happening.
We can also do that if you want. If you want, yeah. For example, let's do that. Okay.
I try to understand. We start from the general to specific.
Yeah. Because we started by this except of Euclid as example. Yeah, of course we can start by figure and then, for example, by geometrical entities.
Yes.
Okay. You can start.
These are also classes.
Yeah. They are all classes. We decided to starting by rectilinear figure just as an example, okay? But if we want to create figure, for example, okay, we have now the possibility to click here on our thing and then add these subclasses that Fotini said, that is figure, okay? But now, as you can see, we have two sibling classes, figure and rectilinear figure. So we can drag and drop rectilinear figure under figure, okay? Just to create a subclasses of a more general class that is figure, okay? So the options are two. We can create all the classes first, and then by dragging and dropping, we can create our hierarchy, or we can create for the first time, from the very beginning, our hierarchy, okay? So, for example, we have figure, we have rectilinear figure, and by clicking on rectilinear figure, we can create our other two subclasses here, by clicking here, add subclasses, that were triangle figure and quadrilateral figure, okay? Let's do together. Do you need help, Laura?
Yeah, to create the subclasses.
Yeah, you go here.
Okay.
You can see that This is the bottom to create the subclasses, and this is the bottom to create sibling classes, classes that are on the same level. Okay.
Thank you so much. Yeah.
So we will create a trilateral figure. And then, okay, here you have two options. Okay, we can create a sibling class of trilateral figure, so quadrilateral figure, or we can go here, rectilinear figure, and create a subclass. Okay, it's the same as you want. If you need, I go slowly, please ask me. It's good. So, for example, here sibling, and I create quadrilateral figure. So this is our first little hierarchy, little ontology. And if you want, we can visualize this little hierarchy by using the plugin Alviz. No, sorry, maybe it doesn't work here. We can try by using Ontograph, maybe it's better. And then you can expand the hierarchy and see what we created. It's Ontograph here, the tab here. If you activated before this tab by clicking on Ontograph here, you can visualize the little hierarchy you built. Okay. And for example, here you can see the information already formalized. For example, that trilateral figure has a superclass rectilinear figure, okay? And the URI connected with this class, okay? This is just to visualize your hierarchy. A chat, maybe there is a question. Oh no, okay. Is it okay for everyone so far? Okay, so let's continue. We just created classes, but we didn't define anything. We didn't define these classes. What a rectilinear figure is, what a quadrilateral figure is. We just arrange these classes in a hierarchy order. So let's move on. Go back to my slides. Okay. So let's continue. This is a hierarchy, but we already done. Okay, and annotation properties. We can associate these classes we have just created with some annotation properties. Here are the main annotation properties given by default by Protégé. You have, for example, RDFS label that provides a human-readable version of a resource name. You can put the name in English, in French, in Greek, and as we will see, you can specify the language of the label associated to that class, okay? We will see that in a few minutes. And then RDFS-C also, that is used to indicate a resource that might provide additional information about the subject resource. For example, there is another ontology about geometry that defined the concept of trilateral figure. And so by means of the relation C also, we can link these two concepts. And in this way, we can provide additional information. Then we have comment that might be used to provide a human readable description of a resource and is defined by Please pay attention that RDFS is defined by, is not the definition in natural language of a concept, okay? You cannot use this relation to define in a natural language, the concept we are formalizing, okay? Because is defined by, is used to indicate a resource defining the subject resource. And this property can be used, for example, to indicate an RDF vocabulary in which the resource is described, okay? So it's just to define the vocabulary you are using to describe your ontology. I provide you with some three main vocabularies used, namely FOAF, which describes characteristics of people and social groups, Dublin Core, that is 15 main metadata items for describing digital or physical resources, and then SCOS. We will use a property taken from SCOS, that is definition. And by using SCOS definition, you can give a natural language definition of the concept formalized in the ontology, but not by using is defined by, okay? It's another semantic. They have two different semantics. So, for example, we will not use this today, but it could be useful. You can introduce on the box annotation property, the FOAF property depiction, and add content of a digital image. For example, if you have an image of a triangle, if you want to associate to a class a specific image of that triangle, you have to use the annotation property FOAF depiction. And then there are some SCOS annotations, so SCOS relations that are very useful. For example, SCOS definition, we will use it in a few moments, and is used to provide a plain text, as I said, definition. SCOS note that is used to provide any kind of information, is just some note that you can write down that is useful for you. And then we have three kinds of label. Well, as you have seen, we can use the RDF label. It's a really general annotation property, but we can also specify which kind of label is. For example, we can use SCOS alt label if you want to specify that is an alternative lexical label for a resource. For example, if we have acronyms, abbreviations, spelling variants, or we can use the property SCOS hidden label. That is a label that is hidden when generating visual displays of the resource, but accessible to free text search operations. So you can retrieve this information by querying the resource, but is not visible, okay? And then we have SCOS pref label, that is the preferred lexical label for a resource, for a class, okay? If you want to specify which kind of label is. So let's continue by associating some annotation properties to the classes we already created in Protégé. So we have to click on annotation property, classes. And for example, we can add some labels in the languages you prefer. For example, we will start by rectilinear figure. And then we click on annotation here, plus, and then annotation. And you can see all the annotation properties already provided by Protégé. Okay, so you can find is defined by, labels, see also the properties we previously defined. However, for example, if we wanted to add some SCOS annotations, for example, SCOS definition, we can do that by clicking here, for example, and add our SCOS properties, that is SCOS. You you have always to put the prefix, okay, of the vocabulary you are taking the relation, SCOS definition. We are creating a new annotation property just to give the definition of the concept in natural language, okay? So now you can see here SCOS definition, and here you can put your definition. For example, rectilinear figure. I will go there. Rectilinear figure. For example, the definition given by Euclid are those figures contained by straight line. I will copy and paste. You can put what you want. And here. Sorry, Piccini.
Can create this way by clicking here.
If you click here, you are creating a sub-properties, okay? So you can find this because you define this as a sub-property of comment. You have, okay, you have to click here on this button because you are adding sibling properties, okay? If you click here, you are adding sub-properties, okay? Sub-annotation properties. In this case, is not our case. So, and then you can put the definition. For example, in this case, the definition given by Euclid, rectilinear figures are those figures contained by straight lines. This is a definition in a natural language of the concept rectilinear figure in our hierarchy. Okay. If you want to try, you can also add some definition for quadrilateral figure and trilateral figure if you want just to try one more time. But we can also add some labels, okay? So the labels used in natural language, for example, in English or in Greek, to designate a specific concept. For example, rectilinear figure. So we can just select RDFS label and enter the label in the language as you want, okay? You can decide a language. For example, I chose Italian language. I can put the label in Italian.
And choose the language.
And then, yeah.
From the list.
Yeah, and then unlock, you can choose. If there is no, there isn't the language you are chosen, you can add it. Okay, for example, eat, I can add it. This is in Italian. Okay, by using the ISO codes.
It doesn't have ancient Greek,
No, unfortunately, yeah. For Greek, you have just to put Greek. But you can also, okay, it's in time, yeah. But you can also add two labels for the same language, okay? Because, for example, if you have synonyms, so you have two terms that designate the same concept, you can add another label and in that language and choose the same language, okay? For synonym. I will put also, for example, in English. And just specify the language. Oh, yeah, voila. Okay, and for example, if you want to add some images, you have to create the FOAF property depiction, as we already created the SCOS definition. So for example, I create another property that says SCOS depiction, and you can add an image, okay? if you want. You can put the link here. Then you need a link. Yeah. An accessible link, and then you can visualize the image. I suppose you cannot visualize if you put, you need a URL.
I sent one.
Yeah.
I want to try.
Yeah. Oh, sorry.
Can I ask you
Yeah.
why I added the label with the language and it turned out that it changed my name?
Yeah.
Yeah. Yes.
Oh,
Yeah, because because in Protege you have also the opportunity to, because in the hierarchy we are at the conceptual level, so we are naming these entities in a natural language, but we are in a conceptual level so they are not in natural language. Okay, you can specify the name in natural language of this concept, and in Protege you have also the possibility to see the name here. Okay, for example, if you previously put not the term figura trilatera, trilateral figure, but for example the concept 9-4. Okay, now you can see the label just to recognize the concept. Okay, this is a possibility in Protege.
How can I do if I want to display the labels in English or in French or in Greek? Can I choose it?
Yeah, but I will see, because I will check how, because maybe.
I find to let me work in English. Do the same thing. So the type of English.
This is production.
You can do the same.
Okay.
Let's do the same. Change the time.
I will see, because
And now, can I display? If I want to display the labels in English.
There is only one. There is no, because I didn't create any.
okay, you can create another one.
Yeah.
Let's try. I will then I will show you.
And now, if I want to display it, to actually select it.
No, antograph.
No, it's not a graph. Is display the
I don't know now.
what is it? It's in Macintosh. Okay, Mac.
I think that I have to say this here.
Wonder by itself is to wonder by.
Rendered by,
That's okay.
we will see together.
So
Rendered.
you have to make for each of them.
Converted.
Yeah.
The same.
Yeah. If you want, but the label is usually used to put the label in a natural language, not a link. Okay, but if you have an image, this is what.
Change I can remember the not quite the name here. It's changed dramatically.
Yeah, because because you go here.
Again.
It was view. Okay, for example, you can choose how to render the name of the ontology. Okay, for example, if I choose, I didn't choose the option render by labels, but if you choose render by labels, for example, here, okay, you can see that the name of the concept changed.
Yeah.
Okay.
If we choose by entity,
Yeah.
it returns to.
Yeah. It's just as you wanted to visualize the information as you set up the, okay? To go to view, and then you can choose if render by entity or by prefix name or by label, etc. You can choose.
May I ask something?
Yeah,
Yeah,
Maybe,
in
yeah.
this
I don't know,
in the SCOS depiction,
as you want. It's the same.
in the SCOS depiction, you said we put the URL, correct?
who have computers, they can watch from the computers, but this, I don't know if the
Yeah, it's not so,
persons that
yeah.
can watch from the screen.
Maybe
So
now
we-
it's closing again. Then
Yeah,
Yes.
yeah, okay.
May I ask
There is
something?
no, okay, okay, it's your,
Dimitri says something, I think. Turn on your audio
oh, okay.
so we can hear the people from.
Okay, hello from Heraklion.
Okay,
Just a second, Dimitri.
Yes.
wait, this is
The-
my,
Your audio, the computer audio.
yeah, it's okay. It's the maximum.
Oh,
1, 2, 3.
so Dimitri,
Oh, it's my audio.
1, 2, 3.
I mute, okay,
Now,
okay.
ακούγαμε. Τέλεια. Perfect. Now, my question is just a clarification. In the SCOS depiction, we said that we have to put a link, a URL, correct?
Yeah,
In my case,
yeah,
well, I have downloaded the Protege on. I have a Linux machine anyway. It doesn't. It gives me also the ability to declare a data type, whether it is a decimal string, integer, the Boolean, whatever. So it's not technically forced to have a URL there, or I actually I can write anything, and maybe it will be a correct URL or not, or it is the case of my of the version of the software I have downloaded. I don't know.
Can you hear?
I will answer,
Choose one mic, closer.
close my,
Sorry, I didn't
okay,
hear.
sorry. Okay, yeah, you can put anything, but if you want to visualize something, you have to put the correct link, and the image needs to be accessible, free accessible, okay? So you can also check the license of the
So,
image that you chose.
I see. So it is up to the human
Yeah,
what to put, and this
Yeah.
is somehow
yeah.
a principle of the software, so that we put any information on our responsibility, and the software leave it to us.
Yeah,
Okay.
yeah, 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 that's the point, yeah. Yeah.
So sorry to interrupt, but all microphones are muted.
Can you hear me now?
Dimitri, can you hear us?
Pause.
Can you hear me?
Yes, of course. Yes.
Okay, sorry. So I said that you can also add some annotation properties at the level of instances. So for example, in the rectilinear figure, you can add some instances. You can populate your ontology, for example, the triangle that the figure that Euclid drawn in his notebooks. And then you can add, this is a specific instance of the class triangle, okay? And you can add here other annotation. You can use all the same, okay, I didn't create any individual. You can add all the annotation we already seen, okay? So for example, you can add a picture, of course, an image, you can add the term, the label, etc. Okay, so annotation is at the level of the concept and at the level of instance, okay? Today we are not populating the ontology, we're just working on the intentional level, okay? I will explain better later. So just at the level of concept and not instances, so specific individuals that belong to that class, okay? Well, let's continue. Okay. So we worked with annotation properties, and now we are going to add object properties. Object properties relate individuals, instances, to other instances. As I said, we are not going to populate our ontology, but object properties will be useful also to define the intention of a class, okay? As we will see. Okay, as far as the object properties are concerned, we have to specify the domain and the range of these object properties. So, for example, we will see that we can add a new object property, and then we have to define the source class of the relation and then the target class for the relation. For example, here you have the relation works for, and we have to define, for example, that the source class of this relation is a person, and the target class, the range of this relation is a company, okay? Why it's important to specify the name and the range? I give you some examples. For example, consider an object properties works for. If we define the domain of works for as a person, as we did, it means that if an individual X works for Y, then X is inferred to be an instance of the class person, okay? So it's very important from an inferential point of view. And the same thing is for the target, for the range of the relation. So, for example, if we define the range of works for as company, it means that if an individual X works for Y, Y must to be an instance of the class company. Okay, so every time we define an object properties, we should define the domain and range as well. Maybe it's more visual. Okay. We can also define the properties, okay, of we can describe these object properties. For example, we can say that is child of or is parent of are subproperties of is relative of. So we arrange hierarchically also the object properties. We can state, for example, that is married to and has spouse are equivalent properties. We can say that is child of is the inverse property of is parent of. And we have also the possibility to use the disjoint with. So, for example, has child and has parent are disjoint properties, just to describe the properties of the relations between the individuals, okay, between the instances. And then we can also specify if a functional, if a property is a functional property, for example, has spouse, each individual is supposed to have at most one spouse. okay? Or inverse functional property, like is citizen of. Each individual is a citizen of at most one country. The symmetric property, like is sibling of. Siblings relationship is mutual. So if A is sibling of B, B is sibling of A. This is symmetric property. Asymmetric property is, for example, is parent of, because if A is parent of B, B cannot parent of A. Okay, is the inverse, is the opposite of a symmetric property. Okay, symmetric property is mutual.
What's the difference between inverse and asymmetric?
Okay,
Sorry.
it's asymmetric because inverse is it's symmetric. Sorry. I didn't use the correct terminology. You have to say asymmetric. That is the opposite of symmetric, okay? Asymmetric, it means that if A is linked by means of a property to B, B is not linked by means of the same property to A. Cannot be reversed.
Okay, but in the same thinking, is citizen of means that I am citizen of Heraklion, but Heraklion cannot be a citizen of me.
Yeah.
So it is also asymmetric.
Yeah, that's why I said I used the not correct terminology. Inverse is not asymmetric. There are two different things, okay? So inverse, of course, if an individual is, for example, in this case, A is a citizen of B, B is not a citizen of A, okay? So inverse, it doesn't mean that it's symmetric, okay? Because it's inverse functional property. It's not just inverse property, it's an inverse functional, okay? So it's are two different concepts. And then we have transitive property. For example, it's ancestor of, or for example, from a linguistic point of view, the synonymy relation is a transitive property, because if A is synonym of B and B is synonym of C, A is synonym of C. Okay, so it's transitive from a linguistic point of view. Here, from a conceptual point of view, we have, for example, is ancestor of. And then we have knows. This is a reflexive properties. So, for example, everyone knows themselves. And irreflexive properties is taller than. No one is taller than themselves. Okay. So just to define some characteristics of the object properties you introduce to model your domain. You can choose if specify, for example, whether a property is functional or is inverse functional or is symmetric. It doesn't matter. It's obviously it's important from the point of view of the inferences you can retrieve. Okay, you can have. But the first thing is to define the domain and the range. And then you can choose if you want to define also all these characteristics, okay? So let's create our object property, just one, that will be useful to define rectilinear figure, quadrilateral figure, and trilateral figure. So let's click on object properties. And then we add our object properties, that object property that could be, for example, has side, okay? Because we have to define that, for example, a trilateral figure has exactly 3 sides, okay? So has side is an object property that can be useful for our domain, okay? So we add this object property here. We click on add sub-object properties and we enter the name has side.
Sorry to interrupt again.
Yeah,
So
no.
these properties are independent of the classes. I mean, are universal for all classes.
No, we have to define now the
Okay,
domain and the range. Yeah,
Okay,
of course.
okay.
Okay. Yeah. For the time being, we can define, for example, the domain that is figure, because figure has sides, okay? So we can specify that the domain, by clicking here, you can choose the class, the concept that is the domain of this relation, okay? So the source of this relation, and in our case is figure, okay? It's the most general. And if we state that figure is the domain of our relation as sides, we are stating that rectilinear figure, quadrilateral figure, trilateral figure are domains as well of our object properties, okay? So I select. Okay, you have to choose, of course, the object properties, and then you can choose the source, the domain of your object properties. In our case, is figure, and click OK. Okay. If we go back to our classes, as we know, also, as we have also to define, for example, acute, let's see, the other classes I put there, for example, right angled triangle, obtuse angled triangle, or acute angled triangle. Or we, for example, have to define rectilinear figures as figure contained by straight line. We have also to introduce the concept of line and the concept of straight line. And in the case of our triangle, we have to introduce the concept, the class of angle, and all the kind of angles, such as right angle, obtuse angle, and acute angle. Of course, okay, so let's do that. If you need help, I'm here. I'm doing with you. So we have to create another class which is not related, is not a subclass of figures. So I go here and I create, for example, the class line and the class angle. And then the different kind of lines and angles. In our case, the line, it will be useful to create the class straight line as a subclass of line. So I click here and go there, subclass of, and I introduce the concept of straight line. And then, for example, all the angle. Acute angle. And maybe we need all three kind with right and obtuse, yeah. So acute angle, for example, and its sibling, right angle. And obtuse angle. Okay. You are ready? Okay. So now, for example, if we go back to our object property has side, we previously defined the domain, but now we can also define the range. That is, for example, what could be the range of our object property as side? What does this object property link? A figure and yeah.
Lines or straight lines, actually.
Line, more general, because figures can be also characterized by not. Yeah. But that will be the definition of triangle. This object property, more general, can link figure and line. Okay. So we create a side line. Every kind of line. For the time being, we have just created straight line, but we can create other kind of line, of course. What? Now we will focus on trilateral figure and quadrilateral figure, and then if you want, you can focus on the different kind of triangles and trying to formalize it by yourself. Okay, just an exercise. Let's see how to formalize. So, for example, this kind of rectilinear figure, quadrilateral figure, and trilateral figure. Let's see in detail. Okay. Online, is everything fine? Yeah. Okay. So I will continue. So we spoke about object property characteristics. Now, let's go back to our definitions. We said that rectilinear figures are those figures, and we said that rectilinear figures are figures, okay? But we have also specified that these kind of figures are contained by straight lines, okay? Because this is the definition of rectilinear figures. Formalizing that rectilinear figures are subclasses of figure is not enough. Okay, so let's start by seeing the most complicated part of the use of Protégé. So we have to define this class by using property restrictions. Okay, so defining classes as property restrictions means creating classes based on the properties that instances of those classes must satisfy. Today, we are going to use 3 kinds of property restrictions: existential restrictions, some with the restriction sum, the existential restriction sum, universal restriction with only, and after, for triangles, we will see cardinality restrictions, okay? So let's start. Universal restriction. Okay, we have to define that rectilinear figures are figures contained by straight lines, okay? So if we have the relation has a side, we have to say that rectilinear figures, the set of rectilinear figures, are a set of individuals characterized by the fact of having straight line as a side, okay? That clear? Okay, perfect. So let's start by doing this in Protégé. rectilinear figure. So, as I said, rectilinear figure are a subclass of individuals, of a class of individuals that are characterized by the fact of having has side, straight line, and the restriction type is only, because we need to say that rectilinear figures are characterized only by straight lines, okay? As usual, to just specify straight line and the only universal restriction, okay? Yeah, so the restriction. Yeah. Why we put the restriction? Because you are defining the trilateral figure, the set of trilateral figures as a subset of a class where the individuals are characterized by the fact of having as a side a straight line from a logical point of view. Okay. You create the class that individuals that has as a side only straight line, and trilateral figures are a subclass, belongs to that class. So this is a subclass. Yeah. Is that? Let's see. Here is the definition, the description. Here is just a hierarchy, okay? Now we have to define intentionally the concept intentionally. What does it mean to be trilateral figure? And here you have the description, the intentional description of the concept, the characteristics of the concept. Okay, I will, okay. Okay, as Fotini noted here, okay, we have, sorry, I can find my ontology. Okay. Here we have the hierarchy, okay? But we didn't define here the concept, what a rectilinear figure is. To define this concept, we have to use this part of Protégé, that is description. We are describing what a rectilinear figure is by using property restrictions, okay? This is just a hierarchy. We are not defining anything, okay? And the main way to define a class in Protégé is by specifying the instances of this class. Okay, so you can define a concept from a class, from an extensional point of view. You define all the individuals, the instances that belong to that class. For example, the class students, and we are all instances of the class students, for example, okay? And we are defining the class student from an extensional point of view by specifying the individuals, the instances. Now here, we are trying to define from an extensional point of view, trying to define the characteristics, the abstract characteristics of the concept we organized in a hierarchy. We previously organized in a hierarchy, okay?
And all these variables certain variables. What are the
Okay, subclass of you use when you, in this case, okay?
I
And
understand that they're goal, but are they something?
Are
A
they-
property, a variable, a parameter, what are their how they
here, for example, the instances, you can add all the instances. So, for example, rectilinear figure, if you have specific rectilinear figure, for example, you are drawing on your notebooks, this is an instance of the class rectilinear figure, or specific rectilinear figure that is drawn on Euclid elements, okay? For example, this is instances, specific individuals that belong to that class, okay? And disjoint with is very interesting. We can use this. For example, okay, in OWL, by default, two classes can overlap. What does it mean? It means that, for example, by default, individuals that belong to a class can also belong to another class. Okay, by default is that if you don't specify anything, this is the statement by default, okay? But for example, in our case, quadrilateral figure, the instances of the class quadrilateral figures cannot belong to the class trilateral figure. A figure is trilateral or quadrilateral, cannot be an instance of both classes at the same time, okay? So in that case, we have to specify that quadrilateral figure is disjoint with trilateral figure. So we explicitly state that the individuals of quadrilateral figures cannot belong to the other class, okay? So let's do that. Thank you, Fotini. You remember me, or remind me that it's very important. For example, if we click on quadrilateral figure, and I click on disjoint with, I can choose the class. And for example, in our case is trilateral figure. So let's go to quadrilateral figure. Let's click on disjoint with and choose trilateral figure and click OK. So in this case, we can see that we defined quadrilateral figure as disjoint with trilateral figures, okay? And you can see the same statement on trilateral figure automatically. Because if you define that a class, it is A, it is joined with a class B, automatically B is disjoint with the class A. Okay, so you can see if you click on trilateral figure, you can see here that this class is disjoint with quadrilateral figure automatically. Okay, because from a logical point of view, if A is disjoint with B, B is disjoint with A. Okay.
If we have two
And of
classes
course,
that are not, sorry for the question. If we have two classes that are not disjoint, doesn't mean that they are the same class.
it means if you don't specify this, it means that an individual of that class can belong to other classes as well.
Yeah, okay. But
Okay.
I cannot conceive
Yeah.
the meaning when there is a set of instances that of a class that some of them belongs also to another class, but the rest of them cannot belong to that other class too. This is just a conceptual.
Yeah, but from an individual point of view, okay?
Yes,
So
yes.
instances point of view, yeah.
may I ask something more? Yeah. So the description are for the description of the characteristics of the
Concept.
okay, and the annotations, what's the difference? Why we shouldn't use the description of the
Okay, yeah,
in
it's
the
a really good
annotations.
question, yeah, because annotate, what you put on annotation, for example, you can describe this concept, no? And on comment, no, you can say that is a figure that has exactly straight line, or for comment, or by using Scott's definition, okay? But from the point of view of inferences, the information you formalize as annotation properties are not usable, okay, by the computer, yeah, by the system.
Just
Yeah, natural language. So you are not formalizing anything, okay? So the computer, the system cannot use that information for inferences, okay?
Description or the annotation.
On the annotation. No, the annotation. The description, on the contrary, the system can use the information you are describing on description. For example, as we said, as we have seen, if you define quadrilateral figure as a class disjoint with trilateral figure, the system understands that trilateral figure is disjoint with a quadrilateral figure. They are information in a machine readable format. Okay. Yeah.
But the class should follow instances also.
Yeah.
But the annotations is like just labels.
Yeah. Yeah. And after we.
Universal.
Yeah.
Labels.
Yeah. And after we will see that, for example, you can put, as we already done, some linguistic information by using, for example, RVFS label. But we can also specify it in a formal way by using OntoLex-Lemon. So the linguistic information can also be used for querying the resource. In this case, if you formalize the linguistic information by using annotation properties, you can use this, okay? So for example, you can use to have inferences, okay? We will
For
see.
instance, I mean, how can you persist on the in this?
In this case, for example, if you say that a concept X, for example, rectilinear figure, is denoted from a linguistic point of view by the term figura rettilinea, and by, in English, rectilinear figure, and then by in Greek, etc. The system can infer, for example, that these three terms are equivalent. Yeah, not synonym, but because we are not in the same system, language system. But no, but it's okay. It's a conceptual synonym. It's an equivalence. Yeah. Okay.
Yes.
Yeah. Do you have questions? Is that okay? Okay. Well, now let's go back to our presentation. Where is what? Okay. So we defined that rectilinear figure are figure that is characterized by the fact of having as a side a straight line. Okay. Okay. So let's now do some exercise about triangles. Okay. So you can take 10 minutes maybe to formalize, for example, from a hierarchical point of view, okay? Acute angled triangle, equilateral triangle, but we will focus mainly on the triangles classified from the angle point of view. So you can add the subclasses obtuse angled, right angled, and right acute angled triangle, okay, as a subclasses, of course, of trilateral figure. If you have any problem, I'm here.
And of course, a shorter way for that, as Rachel taught me the day she arrives, is that you just right click on the upper class that you want to create add subclasses, and you just, it says add subclasses.
Yeah, yeah.
And you
You
create
can,
in each
yeah.
line one subclass.
Yeah, there are two ways of creating, yeah.
Won't wait. So now we are doing the exercise, right?
Yeah,
If we go over there to see if the people have any questions. There,
yeah. Okay.
And
You're doing some exercise. Si tu veux intervenir, c'est que ça.
What the different negotiations?
Yeah.
it's here.
And we will see now. You can see the concept of continuity, the characteristic of the subclass. So this is, we have some milk. So that's heritage. She's
Yeah, just yeah. So it could be very, very complex. Yeah. Yeah.
Especially when we use stadium to export it.
anytime we have yes.
And
Until half past one.
one, yeah, exactly.
Okay. So but we have almost finished the conceptual level. Then we work on the
What are they doing? I mean,
which is in the afternoon.
in
We
the-
will work, yeah, with OntoLex-Lemon.
So as you see, things,
Yeah. Okay, good.
you are so perfect that everyone has become an expert. So, and it was the same with the first conference.
Many tabs to explore.
Yeah,
Yeah.
yeah, but
But everything is linked.
yeah.
And this is
Yeah.
framework.
Yeah, for example, here you can, if you go here 5 and save as, for example, you can export your ontology as RDF or OWLs. Yeah, okay, you can choose and you have your RDF. Yeah, the basis of technologies is XML.
simplifying, you can possibly text editor and you will see the outlets and of the
Yeah, that's
yeah.
just to be more clear. Okay.
Yeah.
Yeah, I'm waiting just 2 minutes. Yeah, just to clarify what me asked me. Yeah, because I skipped all the theoretical part. It's just a practical session, but it's important to define some characteristics. So when you are ready,
So the LDF, if I don't. LDF model.
yeah, it's a meta model. Yeah, it's a meta model because it's based on statements in the form of peoples. Okay, so you have the subject, you have the predicate, and you have the object. And the predicate is the object property. For example, we have seen this is the predicate that link to resources. The first one is, for example, the class figure, which is linked by the predicate, the object property as a site by another resource that is a straight line. Okay, this is how RDF works as a triple. Okay.
So
Yeah, you can have
a data focus.
Yeah.
Yeah.
or a number.
Yeah.
Like it's
Yeah, it's based on, okay, RDF is based on, okay, let's see together. It's more expressive than XML because you are adding semantics, okay, in a formal way. So if you can see here,
yes, you can compare it.
it's based, but at a different level. This is how Semantic Web works, and it's based on XML. Then we have RDF, which is this data model that works with triples. So, for example, we have a subject, we have a predicate and an object, and the subject and object are resources. In the case of the object, we can, as Rafael said, we can have obviously resources, but also some literal, some strings. So we have data properties and not object properties, as we have seen. But today we are not going in detail with data properties. And then based on RDF, there are other two levels, RDF schema, that add semantics, a bit of semantics on these RDF triples. For example, the concept of subclass of, okay? And then we have OWL, and this is the language we are using when we work with Protégé. And you can add a high level of semantics with, for example, this property restriction. You will see with cardinality restriction. So it's more expressive from a semantic point of view. Yeah. And we have 3 kinds of OWL. And we are working with the OWL DL, namely description logics. Huh? No, it's not specified. It's specified just OWL, which is a big family. And then you can choose which kind OWL. We're working with Protégé, we are working with OWL DL, I mean description logics, because it's based on a subset of the first order logics. And it's good because you can have inferences on this system, is machine readable. Otherwise, we have OWL Lite that is more less expressive than OWL DL. And then we have OWL Full that's really expressive, but the inferences start, I don't know how in English, Yeah, you can not have some inferences, okay? Start with,
Like keep it wrapped,
like,
keep it wrapped.
yeah, but we are using OntoLex-Lemon here now. Okay, just from a theoretical point of view, okay? So we are here now. We are working with the semantic web technologies. We are using, obviously, RDF, triples, and we are adding semantics learnings for OntoLex-Lemon. Well, now if you go, for example, if you click on right angle triangle, you can see here that this concept inherited the characteristics of the upper class trilateral figure. So it's described as obviously subclass of trilateral figure. And since we defined trilateral figure as a side only straight line, right angle triangle as well is characterized by the fact of having as a side straight line only, okay? If you also specified the class, for example, right angle, now you can use cardinality restriction to specify that, for example, the right angled triangle is a triangle characterized by sides as straight lines, but also by the fact of having exactly one right angle, okay? So just to go back to theory, let's see this and then we formalize. This. Here about the trilateral figure, but it's the same thing. You can do this for trilateral figure and then for example, right angle, the triangle. Trilateral figure is a figure that has exactly three straight lines. So we want to specify this and we have to use cardinality constraint. So as you can see here, trilateral figure is a subset of a set of individuals that have three straight lines. Exactly three straight lines. So you put a cardinality constraint. Okay, let's do this in Protégé. So, for example, trilateral figure. Subclass of has side straight line. We can specify exactly three.
So can you show it again?
Yeah. Okay, we'll do again. Rectilinear figure is defined as a subclass of all the individuals that are characterized by the fact of having has side, straight line. So you have to choose the class straight line on the ontology, on your hierarchy. Is that fine? Trilateral. And then subclass of, okay, because it's a subset of a class, anonymous class that is characterized by instances that has a side, straight line, cardinality, exactly, break. You can add, okay.
And side exactly the outside.
Wow.
So I wanted to define an acute angle, you know, that's less than 90 degrees, and I see how we have a right angle, you can say exactly 90 degrees, and we make like a property that's degrees, something like that, but then for something that's less than 90, I see they say like maximum 90. What is that saying? Because an acute angle can't be
In the nice case,
yeah.
yeah. Okay, okay, exactly when you can define exactly the number, okay, if you have a range, okay, you can use maximum and minimum, yeah, yeah,
But what would you say?
Yeah.
Is it maximum as in like equal to at most, or maximum as in it can't be this? And that's
no,
it?
no, it's the first case.
Okay, so if it can't be 90, it has to be less than 90, would you say 89.999?
Yeah,
onwards?
yeah,
Okay.
yeah, yeah,
Master.
yeah.
Okay.
Yeah. Got it. Yeah. Yeah,
May I ask? I have a little confusion in my understanding on something.
course.
I created two object properties. One object property has obtuse angle for the obtuse triangle. Okay, and as a domain, I have this. I have created any obtuse angle triangle, and as a range, an obtuse angle
Yeah,
with a restriction exactly 1.
yeah, but in that case, I
Yes.
would, I would formalize in a just little different way. We have a triangle, and
Yes.
then I will add the relation, for example, has angle, just more general relation, okay?
Okay.
And then for example, obtuse angled triangle, I would say that is a subclass of a set of individuals that has angle exactly 1 obtuse angled.
Okay, that would be a different approach.
Yeah, yeah, but it's the
in
same. It works. It works. It's just
Okay, what is my not understanding is that in the same way in the classes at the
Yeah.
obtuse angle triangle, I have added it as a subclass of has obtuse angle exactly for obtuse angle.
why
I-
for?
Just to test what's going on.
Ah, okay.
But
Yeah.
can I I'm not sure if I'm describing it well. Can I share my screen
Yeah, of course,
to
of course,
show you what am I
of
doing?
course, of
Okay,
course. Yes,
just
yes,
a
please.
moment.
Yeah,
Because
yeah.
I may do something
Yeah.
wrong.
No.
Here it is. So
Yeah.
here it is. This is let me put that away. This is object. Oops, what is this? This is object properties, has obtuse angle, and this is the domain as I have defined it and the range of this relation.
Yeah.
Correct? Okay.
Yeah.
So in the classes, I have the obtuse in the obtuse angled triangle, I have declared it as a subclass of this of
Yeah,
the
subset
relation,
of individual.
but
Yeah.
I put a different restriction, and shouldn't these two be a conflict conceptually? I mean,
Between what? A conflict with.
no. Look. I'm removing this.
Yeah.
I'm removing this, and I say, okay, obtuse angled triangle.
Yeah.
I will put it a subclass.
Yeah.
Of has obtuse angle, which will be an
Obtuse
obtuse
angle.
angle, and we'll have exact cardinality of.
Yeah, you can choose the cardinality. It's up to you. You can also put, yeah,
but now I have a relation where I have defined it that it is valid only when there must be one obtuse angle, and now in my understanding, I'm declaring the same thing, but with another
a
restriction.
wrong cardinality,
Yes, which is a
Yeah.
conflicting restriction. Is it okay? I mean, okay, technically.
Yeah.
So,
It's okay technically, but of course we all know that it's just one obtuse
yes,
angle.
of course. But
Yeah.
my question is,
Yeah.
so I can do whatever I want, and any mistakes is on my responsibility.
Yeah, because you are defining. Yeah, you are defining. The system can just make inferences starting from you, what you formalized. But the assumption is that what you formalized is right. Okay. It cannot check because you are giving the definition.
But my formalization, isn't it obviously wrong in this case? I mean, the system, how can make any kind of inference if I have put two restrictions that are obviously contradicting each other? This is
I cannot understand which statements are in contradiction.
Okay, the fact that I have defined the relation has obtuse angle.
Wow, because you found, okay.
This one, the first.
Okay, because you used cardinality also to define.
Yes.
Okay.
Yes, exactly. This is my
Yeah.
question.
Maybe you can try to start with a reasoner, and maybe it could be.
Okay. There's another step. Okay.
Yeah.
All right. I thought that it would be me. Yes, I see.
Yeah. I'm sorry, I didn't see that you also formalized this cardinality restriction for object properties as well.
All right.
I wouldn't do that. I wouldn't do that.
Yes, that's understandable. Yes. Okay.
Yeah, I wouldn't do that. But if you, for example, then you launch a reasoner, you see the tab reasoner over there.
So we are creating a formalization, and there is another step that checks the formalization.
Yeah, the consistency, consistency of this formalization.
All right.
All right. Yeah. Okay.
Thank you.
No, you're welcome. Sorry, I didn't see that restriction. Okay, so so we defined the trilateral figure. You can also define, just for an exercise. No. Just as exercise, you can also define, for example, here, right-angled triangle, obtuse-angled triangle, etc. Okay, acute-angled triangle, and then I will introduce the linguistic part. Just to use cardinality restriction. So, for example, you can state that a right-angled triangle has angle exactly one.
And
right angle.
It appears to the other.
It depends if it's a sibling or not. Sibling not irritate anything.
Sibling. The restriction here and the acute. And
What kind?
Right.
Yeah. The disjoint width, as I said before, the disjoint width is automatically asserted for the other class. Okay. Yeah, because, yeah, Laura.
We have to define the past properties.
Maybe we didn't define.
No, it's a question. Do we have or is it
Yeah,
already?
yeah. That the object property, we created just one object property aside. We can create another object properties as angle, for example, just to make some practice, okay, to do some practice. Just another property, you can choose how to name this object properties, for example, has angle, and then define the triangles on the basis of these object properties with cardinality restriction.
So the properties of classes do not populate automatically the subclasses.
The prop,
Sorry, they automatically subclass.
automatically subclasses inheritate the characteristics of the upper class, of the superclass. This is right. Yeah, for example, if you have trilateral figure and you defined this figure as a side only straight line, sorry, you defined the rectilinear figure as a class characterized by having only straight line. This axiom is also inherited by trilateral figure and all the other trilateral figure, right angle, triangle, etc. All the characteristics of the upper class is inherited by the subclasses. Yeah, here you can see what the class has inherited in subclass of anonymous ancestor. Yeah. Here, there are what you formally are defining, expressly defining, and here what the system infers. You can add also annotations if you want, labels, definition, etc. What you want, okay? Just to do some practice, and then I will introduce the linguistic level, and we are working on it in the afternoon. So maybe we can start by introducing the linguistic level, okay? And then we will continue this afternoon. Okay. I just provided here some terms, Greek terms, extracted from the Euclid geometry and the equivalence in English, in Italian, and in French. So now we are going to build maybe four lexicons, one for Greek language, the other one for English, the other one for Italian and French, and to associate the lexical entries to the concept we have already defined, okay? So we are building what is technically as a ontoterminology, because now we have worked on the level of the ontology, of the conceptual level, and now we are going to associate linguistic data, the linguistic dimension, to this conceptual dimension by working on with the same software Protégé. Okay. So let's recall just the strategy we already have adopted, that is using annotation property, because we defined the linguistic level by using annotation properties, because, for example, we can specify that a trilateral figure can be associated with different labels. Figura trilatera for the Italian language, trilateral figure for English, tripleuron et sugamon for the Greek of Euclid times, and then figure trilateral for French language, and we have added also a definition in a natural language. However, using annotation properties can have some disadvantages. First of all, as I've already said, we have limited reasoning support because annotation properties are not considered part of the logical structure of the ontology, and reasoners typically ignore annotation properties during their computations. And this annotation cannot influence the inferred knowledge or support advanced reasoning tasks. So the problem is from a reasoning point of view, from the point of view of differences of the system. There is no semantic impact because annotation properties do not carry semantic weight. They cannot be used to define constraints or relationships that contribute to the logical model. And they cannot obviously enforce domain or range restrictions, create class hierarchies, or specify property characteristics like transitivity or symmetry, okay? For example, we cannot specify that two labels in the same language that denote the same concept are synonym, and we cannot specify that synonym is a transitive property. Okay, you can just put labels. Annotation properties are not subject to the same consistency checks as the properties in OWL. The consistency check we have already seen with, I don't remember the name of the participant online, because obviously you can check the consistency of the ontology by using the reasoner, but reasoner doesn't work with the data formalized as annotation properties. So you can check the consistencies of the data you formalized as annotation properties.
Annotations are more useful for.
Yeah.
On the other side, the other data are useful also for machines.
Yeah. This lack of validation can lead to inconsistencies, of course, errors in the metadata. For example, if we have inconsistencies like those said by the participant online, we cannot check that, okay? Because we don't have any formalization for annotation properties. Inconsistencies might be overlooked because they do not affect the ontology logical consistencies. There is other problems with interoperability issues, for example, because different tools and systems may handle annotation properties differently. And the presence of numerous annotations can increase the size of an ontology, and this can potentially impact the performance of some ontology management and editor tool. And this is true, this is the case for very large ontologies with extensive annotations. So the second approach we will see this afternoon is using a model that is called OntoLex model. And this is considered a standard de facto in computational lexicography. And it was introduced with the goal of adding linguistic information two ontologies. So this is the ultimate goal of the creation of this model. It's developed in the context of W3C OntoLex community group. And you can see the report, the final report at this link. As I said, the aim of this model was to enrich ontologies with linguistic information, in particular with information concerning how ontology entities, namely properties, classes, individuals, can be realized in a natural language, can be lexicalized. And one of the key benefits is the ability to link this lexical data with ontological concepts, okay? So this is the main goal of this model. So I will say that we can continue this afternoon. I will leave just these 5 minutes if there are questions, if we have to go back to some concept, I don't know. And then we will start by illustrating the main characteristics of OntoLex-Lemon. That is a monstrum because it's really, really big. It's characterized, as you've seen, as this modular architecture. There are a lot of modules, complicated modules. We will work with the core today, obviously, and maybe with the composition module. And maybe if you are good, and I suppose you are good students, also with the translation, okay? How to link different lexical entries that belong to different lexica by means of the relation translation, by using this module that is called variation and translation.
Okay, thank you very much, Silvia.